Here we go. Yeah, it's harder than yesterday for sure. All right, 5.1b. So extreme values. Actually, I should say critical points, but that's okay. There's a big difference between extreme values and critical points. All right, so here we go. We learned yesterday in our notes and everybody. Thank you. Thank you, Kevin. Oh, happy birthday, Kevin! Wow. Now, yesterday we found out that in order to find any of your critical points,
so is this about extreme values?
Yeah, well, it's critical points. You're going to find all the critical points. You're going to find out if they are extreme values or not. To find your critical points, what you're going to do is, first of all, if it is on a closed interval, then you need to check A and B. Okay, those are going to probably be maximums or minimums if it's on a closed interval like that. The next thing you need to do is you need to set f prime of x equal to 0. And you also need to set f prime of x equal to 1 over 0. Because that's where it's undefined. All right, so let's do it. Here we go. Yesterday you were able to look at a graph and find its maximum and minimums that way. Now we're going to not have a graphing calculator, and we're going to have to find them on our own. So let's take a simple parabola. F of x equals x squared minus 5x plus 7. But let's not make it the entire parabola. Let's restrict this on the interval from -1 to 3. Okay. What I'm going to do is, on your quiz, I'm going to give you a table to fill in for me. Okay? It's going to look like this. Critical values, x equals. Okay? The second part is going to be f of x. And then the third part will be, what kind is it? Is it a max or min? Is it relative or absolute? Relative, absolute. Okay? All right, so here's what you want to do for this. First of all, your critical points will be the endpoints, so you need to make sure that you include those first. So at x equals -1 and at x equals 3. Now, a lot of times in like your AP calculus classes, they won't let you use your calculator at all. And so you'll have to take -1 and actually plug that in by hand to find out what f of x is. Okay? You might not like that, but you can do it. You can plug it into your calculator. That's fine. It's really not that bad, is it? It's 1 plus 5?
Oh, yeah.
Plus 7. I know, it's easy to mess up. Oh, another way to do this. Is it 13? You got 13? Yeah. Me too. Another way, if you don't like that and you don't trust yourself, you can always do synthetic division.
No.
1, -1, -6, 6, 13. No? That's good. That's really good. Yeah. Molly likes it. The remainder theorem says that f of -1 is 13. Whatever your remainder is what it's going to be. That's synthetic division. I like it, especially if you get really big numbers and they're complicated and you don't have your calculator. All right, then don't do it that way. Forget it. Okay, and then what about 3? Did you plug 3 in? Does it? So 9 minus 15 plus 7, 1. Thank you. 1. Okay, now the next thing you need to do is you also need to see if the derivative, and the derivative is never undefined. It's a polynomial, a nice smooth curve. So then you have to find out where the derivative is equal to 0. Okay? So let's take the derivative. F prime of x is 2x minus 5. Good. And so set that equal to 0 and solve. So x would be 2.5 or 5 halves, whatever you want to say. Yeah. So x equals 2.5. Now, sometimes...
So why do you do that?
Because where is the derivative equal to 0? Like, this is just a parabola, right?
Oh, it's on the line.
It's going to be right here. the minimum.
So that makes it greater
Mm-hmm.
So I mean
That's going to be a critical value for sure. Yeah, this parabola. And you know, you don't have to think of this so in terms of calculus. You can think of this as what you learned in Algebra 2. You know what a parabola is. You know where its minimum is going to be. Yeah.
Where did you get to it on the slide?
I took the derivative of the function.
Oh, wait, so then what is, if we have 2.5 there, you have to plug that into
Yep.
the regular?
Into the yes, you have to find f of x, not f prime of x. We know f prime of x is 0. We have to then plug it back in, and you get 0.75. 0.75 when you plug it in. Okay, that's why I let you have your calculator for that. Okay, so now this is what it looks like. And by the way, sometimes you'll take the derivative, you'll find the point, and it won't be in your interval, so you don't need to worry about it. Okay, so look, is 2.5 in our interval? Mm-hmm, it sure is. So now what I do is I try and sketch a little graph of this. I'll go to x equals -1, and I'll plot 13 way up here. I'll call that 13. And then I'll go to x is 3, and I'll plot 1, which is right here. And then at 2.5, which is right here, I'm at 0.75. And then I draw a nice smooth curve through that. Okay? And that's really nice because now I can actually see what I'm trying to find, and I can tell you what the maximum, minimums, all that stuff are. So x equals -1 is 13. That on my graph is a what? It's the absolute maximum. Kind of ran out of room in my little chart here. How about x equals 3? What's that? It's a relative maximum. See how it's higher than the points around it? Yeah, but it's relative because we already have an absolute. So that's a relative maximum. And then what about the point 2.5, 0.75? That's an absolute minimum. And there's the chart, and that's what you have to fill in. Whew, it's right. It's a lot of them, huh? Is it easy? Yeah. Polynomials aren't hard. It's when you get into logs and other stuff. Oh, I'm sorry. And I ran out of room there, too.
You made your thing bigger.
Yeah. Let's do one more polynomial, and then we'll move on to some other stuff. Number 2. Let's do a cubic now. F of x equals x cubed minus 75x plus 100. Now, they don't have to restrict the interval. They could say it's the whole polynomial, but a lot of times they'll tell you, in this case, 0 to 6. But look what I did to the 6. It's open, so it's not going to be a critical point. I'm not going to include that. Okay, so here we go. We're going to do our critical points, x equals, and we're going to have f of x, and then we're going to have what type it is. Is it a max? Is it a min? Is it absolute? Is it relative? Okay, well, 0 for sure. 0 is an endpoint. You have to always include these endpoints. So x equals 0 is one of them. I'm going to plug in 0, and I get 100. Perfect. I do not worry about 6 because 6 is not part of my interval that I'm going to include. Then we have to go ahead and take the derivative. So the derivative would be, 3x squared minus 75. Set the derivative equal to 0 and solve. Are you thinking of this in terms of velocity over here, Mr. Edlin?
You can't polynomial.
Oh, all right. All right, equal to 0. Add 75, divide by 3. X squared is 25. Take the plus and minus square root, and you get 2 points of 5 and -5. Now, check your interval. Just 5. The -5 is not, we don't even care about it. That's the interval given to us, 0 to 6. The only one we want is x equals 5. But do it right, like get both answers, because it might be a bigger interval. Okay, so take 5 and plug that back in. You can use your calculator for that, and it's going to be -150. Okay, so x equals 0. I mean, if you look at it, there's only 2 critical points here. That's going to be a what? Absolute maximum.
Wait, they can't be absolute maximum.
Well, let's see. 0, 100, that's the point. And then
But it's open.
5, negative 150. You know what? We'd have to kind of test 6 to see if it goes back up, huh? Yeah. You know what? I would be okay if you just wrote maximum there. That would be all right, since we're not quite sure, because it's the mean value theorem doesn't happen here, so we don't need to worry about that. And then negative 150 is going to be way down here, and so that's going to be that, and who knows where 6 is. We don't even care. So that would be in the then there doesn't have to be an absolute anything. There could be, but there doesn't have to be. So we would just write max and min. And the book's not too particular about if they're relatives or absolutes. Okay, let's do a weird one now. Are you ready for some weird ones? The polynomials aren't weird. Polynomials are nice and easy, and they make you feel good about yourself. Okay, let's do this one. G of x equals x to the 2/3, gross, on the interval from negative 2 to 3. So let's go ahead, and what we're going to do is we're going to have our x value, our f of x value, and we're just going to do max or min. Okay, I'm going to let you just do max or min on these, because I don't even think the book asks you for absolutes. Alrighty, so I always start with the endpoints first, because I know that I need both of them. So I have x equals negative 2 and x equals positive 3. And we're going to round to 2 decimal places here if we need to. So let's go ahead and evaluate what f of negative 2 is. If you have an older calculator and you're raising it to the 2/3, make sure you put parentheses. Yeah, what'd you get? Negative 1.59? Yeah? Okay. And then do 3 to the 2/3. Did I do it wrong? Oh, I did it wrong. It's positive. Positive, thank you. It is positive, because it's negative 2 to the 2/3. Yeah, I didn't. I should have. I yell at my Algebra 2 kids all the time about that. Mm-hmm. Yeah. You're squaring the negative 2, and then you're cube rooting it.
2.08.
2.08. Yep, that's what I got too. 2.08. Okay. Now let's go ahead, and we're going to take the derivative. What happened?
Why do you put parentheses on 2?
Because we're doing negative 2 to the 2/3, you're squaring the negative 2. And when you square a negative number, it becomes positive. And then this is the root. Just taught that in Algebra 2 today. They hated it. This is the cube root of negative 2 squared. Okay, and now let's take the derivative. Are you ready for the derivative? Because it's ugly. G prime of x is equal to 2/3 x to the negative 1/3. Good. All right, so this is 2 over 3 cube root of x. All right, so this doesn't equal 0 ever, right? Because in order to have a fraction equal 0, then you need to have 0 up top. It doesn't. But this is undefined. Where is this undefined? At x equals, I think someone said it, 0. What if you plug 0 in for x? Cube root of 0 is 0 times 3 is 0, so you get 2 over 0. Okay? So that is a critical point. Just because it's not, the derivative doesn't equal anything there, we still need to list that as a critical point. Yeah?
So we just plug in that situation, just plug in 0 for x?
Yeah, you know what I like to do? I like to set this equal to 1 over 0 in a way. Like that. So you're really trying to find out where the bottom equals 0. It's kind of like finding the domain of something. You're trying to find out what would make the denominator 0 here. Because you can't have 0 in the denominator. So you just do that. All right, now plug in 0. What's 0 to the 2/3? That would be 0. Okay, so what I would do is I might sketch a little graph of this. So I'd go over here to negative 2, and then go to 1.59, right here. and at 0, 0. And then over here at 1, 2, 3, I'd be up here at 2.08. Now, you know what this looks like? It's actually, the graph of it is a cusp. That's why the derivative is undefined at 0. There's no derivative there.
Are you gonna give us one like that? Because I totally would have drawn like a graph.
Really?
Because I was just connected the dots.
But you know that it's undefined there. So it's got to be either a corner
But I wouldn't.
Aren't we gonna?
or a cusp. You'll have your calculator. You can graph it.
Okay.
I shouldn't tell you that, but I do. Okay, so at x equals -2, what kind of a point is that?
Maximum?
That is a maximum. It's actually a relative maximum. We don't care. And then at 3, we have a maximum also. And then at 0 is a minimum.
So an undefined point can be a minimum?
Yes. Yep. Okay, critical points can happen at undefined places. Like, for example, if I had an absolute value, this point right here is my maximum, but it has no derivative there. All right, let's do another one. Here we go. Number 4. Sorry, every time. I totally should hand out diplomas like, another one, another one. All right.
Just do it.
No.
Yeah.
I don't know. All right, f of x equals. Yeah. I don't know. Natural log of x plus 1. And let's restrict the domain or the interval from 0 to 3. Okay, you ready? Sure. All right, here we go. Sure. That's my least favorite word. I hate it even more than moist.
Why?
Because it's,
My mom hates that one.
really? It's like you're not committed to yes or no.
Exactly. I'm not committed to yes or no. I'll give you this problem.
But I hate it. Like, do you guys want to go to dinner tonight? Sure.
It's like giving up. Like,
Yeah.
I don't care.
I don't want to go, but like I'll just say yes. 'cause
Right?
I
Yes, I hate that. I'd rather you say no or yes.
Okay,
It
no.
depends on the context.
What if you say sure? That's okay. Okay, here we go.
Sure.
X equals 0, x equals 3. Let's do it. All right, so 0 goes in, and I get the natural log of 1. Do you know what the natural log of 1 is?
0.
0.
Watch the strobes.
What's the natural log of e? Jack, have you not learned anything? How old is Lenny?
I don't think.
You think he pays attention?
Lenny's 1. He's a little baby. He'll always be 1. He's so cute. Okay.
Just
Okay.
take a shot.
So then if natural log of 1, it can't be 1 also. All right, now how about 3? You get the natural log of 4, which is approximately 1.4. Approximately. Okay, now let's take the derivative of this. F prime of x is equal to, now do you remember the derivative of natural log of x plus 1 over x plus 1? Dang. Now the funny thing is, though, is if you set that equal to 0, it's not going to equal anything. But if you want to find out where it's undefined, where is this undefined? At x equals -1. But guess what? We don't care. See our interval? Our interval is from 0 to 3.
So those are like
So
2 points.
those are only 2 points. Exactly.
Watch us all make that mistake.
All right, so this one right here at x equals 0, this is what the graph would look like. It's 0, 0. And 1, 2, 3, you're at about 1.4. See right here. The graph just looks like that. Stops right there. It's a closed interval. And so we have a minimum and a maximum. That one was kind of a yawner, wasn't it? A little boring.
How was that?
Yeah?
Where do you get this?
What happened?
When does it get hard?
Oh, let's do a hard one.
What is that?
Oh, wow. Thanks, Trevor. Okay, do you want to get to your fate now or later?
Later.
Why?
Yeah.
Get it now.
Hold on, what?
Why did you do x equals 3
Oh, where is this function, where's the derivative undefined? It's undefined when x is -1. It's undefined when the denominator equals 0. All right, Trevor's just like, cut to the chase, let's get to it. Here we go. How about this one?
Find out.
F of x equals x squared e to the x over the interval -5 to 1. Okay. Now before you just do 2x e to the x, you have to do product rule here, Trevor. We forget, huh? It doesn't look like product rule. It's so simple looking. It's so clean. It's x squared and e to the x. But it's a product rule. This is a totally different function than that one. They're two functions.
Derivative right now.
Oh, we're going to. Oh, you're right. You're right. I'm stepping. Yeah, you're right. Good call. I'm getting ahead of myself. We have to do the endpoints first. We don't have to. It's just we like to. All right, so let's go ahead and x is -5. You can plug this into your calculator if you'd like. Don't forget to put parentheses around it this time. I'm talking to myself. And then times e to the -5. What did you get? Okay, I got 0.17. You're going to trust me, huh?
Yeah.
Okay, all right. I hope I'm right.
If I'm not gonna change anything, it turned out good.
Okay. All right. Now let's try x equals 1. 1 squared is 1. E to the 1 is, do you know what e is?
1.2 something.
Nope. 2.72 approximately.
Good try, Jack.
Okay. Now let's go ahead. Before we find the types and stuff, we need to take the derivative of this thing. So here we go. F prime of x. AB prime plus BA prime. So A is x squared. B prime is e to the x. Plus B is e to the x 2x. Alrighty. This is an interesting part. So let's take this thing and let's set it equal to 0. I'm just going to rearrange it a little bit. And we're going to set this equal to 0. Now, this is interesting to solve, right? How do you solve this? We can factor out, yes, an e to the x and an x from both of them. And what we're left with is x plus 2. Okay. So this thing really has 3 factors. It has 1, 2, 3. And in order to find out where it's 0, we need to set each of them equal to 0 and solve. Now, does e to the x ever equal 0? No, it won't. Okay? So that one we don't need to worry about. What about this x right here? 0. And this one? -2. Okay? By the way, if you don't trust me and you're like, how do you know e to the x doesn't equal 0? You can either think of the graph, or you can natural log both sides, or plug it in your calculator. Or when you natural log both sides, you're not allowed to take the natural log of 0. Your calculator won't let you. Okay? All right, so we get 2 more points. Are they in our interval? Yeah, they both are. Gross. All right, x equals 0, x equals -2.
So the point of making it equal to 0 is to see what are the critical points.
Yep.
So is it 1?
So 0 goes in.
Oh, but it's 0 times.
0 squared times e to the 0 is 1, so it's just 0.
Yeah.
Okay? And -2 goes in. So -2 squared
4.
times e to the -2, and you get 0.54. Okay. Now, I'm not sure what this graph looks like, but I like to plot the points to see like how up and down they go. So if I go over here to -5, I'm at 0.17. That's pretty close to 0. I go over.
Don't we know that those are all critical points? So can't
Mm-hmm.
we just know that since like
Yeah, I guess so. You don't really need to graph them, huh? I kind of like to, though, because they're not in order right now. Yeah, I like to see. I'm a picture person. I don't know.
Or like if you put the x equals in order, then you would know, right?
Yeah, if you put them in order from least to greatest, you would know. Yeah, you could do that. That's what I'm doing here in a graphical way. So we're kind of doing the same thing. All right, so 1 and almost 3 is right there. 0, 0, and -2 is right here, and that's a half. So it goes up and then down and then back up. Right? There we go. Okay, so -5, what is that? A maximum or a minimum? It is, it's a minimum. And then it goes from -5 to -2, it goes up from there. So if you want to look at it that way is cool too. So that would be a maximum. And then it drops down to 0, 0, which is a minimum, and then it goes all the way up to here, which is a maximum. Have you graphed any of these on your calculator to check them out too?
Nope.
I want you to do the work. Like, this is kind of an interesting lesson because it's kind of like olden days. It's like, why can't we just go to our calculator, you know, and graph it and look at that interval and see what's happening there? But we just did all of that by hand. I mean, don't you feel like you've accomplished something? I was going to say nothing. No? You don't even care?
Well, I won't be doing it like that.
After this test.
There you go. That's true. Okay. Anyways, all right. Let me see. I think I have
25 minutes, holy.
a couple more.
Only been 25
Well,
minutes.
you guys talk a lot. It's not my fault. All right.
Like, boy, it's so.
Number 6. A couple more things, okay? Number 6. Let's do a rational function. Let's do f of x equals x over x squared plus 9. I'm not going to give you an interval on this one. Okay, so there's no endpoints to check, which is nice. That's okay.
So you check.
So now we got to find the critical points. So we just have to take the derivative.
You can't get it equal to 0.
The derivative, we'll see.
No,
Oh, the function, no. Function you don't need to worry about.
I thought we were supposed to make it
Quotient
one
rule.
over 0.
The derivative, 1 over 0. F
Yeah.
prime.
Oh, yeah.
Okay, so let's do what? Oh, I heard Trevor say it. Yay, you've redeemed yourself. Oh, okay. Did you hear what they said? Quotient rule? Okay, so low d high minus high d low over the square of what's below. All right, now let's fix that up. It's pretty gross, right? F prime of x is equal to, what do we get here? X squared plus 9 minus 2x squared over x squared plus 9 squared. And we'll fix that even. And so we get negative x squared plus 9. And nothing's going to, don't start canceling stuff out. Canceling. Okay? So there it is. All right. And then I ask you a couple of questions. This one's kind of a different one on the quiz. There's one like this. First of all, we need to set this equal to 0 and solve. Okay? So negative x squared plus 9 over x squared plus 9 squared. And we're going to set this equal to 0 and find out where it's equal to 0. Now, if you want to and you get a little confused with trying to solve this, just put it over 1 and cross multiply. And so we're really trying to find out where negative x squared plus 9 equals 0. Now, nobody likes a negative x squared, right? What you can do is you can multiply everything by negative 1, or you can think about moving all these things over. But it's x squared, or you could just add x squared over, I guess. That would be even better. You get x squared equals 9. So x equals what? Plus or minus 3. Thank you. Plus or minus 3.
How come you were doing the bottom at 0 earlier than
Okay, so there's two things you need to check. You need to check where f prime of x equals 0, also where f prime of x is undefined. Okay? In this case, it's never undefined, right? I can put any number in, and when I square it, I'm never going to get 0 down here for real numbers. What's wrong?
Things are just like the same thing. Like they did the same thing.
On this one?
1 0
Oh, really?
0 over 1 and 1 over 0.
Yeah, I don't know what we're trying to find right now. Like, I just know that
Oh.
I know we're solving for x, but
Oh, okay.
it really-
We're trying to find the critical points on this graph. I'll show you what that graph looks like in just a minute so you can have like a visual picture of it. But the way that you find critical points, so the maximums or minimums, okay? And what you do is you take the derivative and you set it either equal to 0 or make sure you find out where it's undefined.
And so the critical points are plus or minus 3.
Yes,
Yes, because there's nothing that's undefined.
right. It's never undefined, the derivative.
You could potentially have
Both.
Both. Okay, so then our critical points are at x equals plus or minus 3. So let's find out what those points are. Find out if we have maximums or minimums or what. So take 3 and plug it in. Go back to your original equation of f of x. So let's find out what f of 3 is. It's 3 over 18, so 1/6. Okay, do the same thing for -3. f of -3 would be -3 over 18, -1/6. All right, so this point right here is a maximum, and this point right here is a minimum. And that's it.
How do you know that?
Because 1/6 is bigger than -1/6 for the y value. Now, let me graph this one for you so that you can see it. X divided by x squared plus 9. Okay.
I know it's 1/6. So it's
Yeah, it's going to be super small, huh? Wow, that's really bad. Let's change our window. Let's go from like -4 to -1. And then y will go from -1 to 1. Let's look at that. Oh, it does that weird little thing right there. That's why this is not that great, right? We can't even tell what it looks like. But we do know that at 3, oh, you could go to the table and look at it that way. Aha. Take a look at this. Here's the table. At 1, it's 0.1. At 2, it's 0.15. At 3, it's 0.16667. At 4, it's 0.16. It goes back down. Do you see that? So it's smaller, it goes up at 3, and it comes back down. But it's really hard to see that on your graph. So doing the derivative and all that is so much better because you can actually see that that's a maximum and that's a minimum. Is this graph ever undefined? No, it's not. Nothing's going to make the denominator 0 here. Okay? So that is kind of a weirder one, right? All right, I've got one more of these, but we're going to do this one graphically. I'll show you how to do it graphically too. All right, so we have y equals the sine of 2x plus the cosine of x. And I believe on the quiz on this one, I give you an interval. On my paper, I don't have an interval, so let me see. I wonder what a good one would be. Oh. Sorry.
Pi or something?
You need to be in radian mode for this, by the way. All right, yeah, so let's do this. I would probably tell you for the interval to be from 0 to pi. Yeah, let's do 0 to pi. I like that. 0 to pi. Okay, here's how you could do this one. And I wouldn't make you do this one using calculus or analytically because you have to take the derivative, set it equal to 0, and that's something that we did in trig. And you really don't want to do that. So let's do x equals, let's find our f of x values, and let's find the type. Okay? So I know 0 and pi are going to be it for sure. And let's look at the rest. So this is what I want you to do. I want you to go to your calculator, if you have it, and go ahead and graph that, sine of 2x plus cosine x. And when you graph it, make sure that, a couple of things, you're in radian mode, and then what I did is I hit zoom trig. Okay, now I'm going to restrict my window, though, from 0 to pi. Oopsie. 0 to pi, so that I can see it better. So there it is. Oh, that's nice. That's kind of boring.
X window?
Yeah.
From 0 to pi?
Uh-huh. 0 to pi. And then what you can do is you can hit trace, and you can actually plug in x equals 0, and you get 1. Plug in x is pi, and you get -1. Are there any things in there that are maximums or minimums? Yeah. And if you were actually to take the derivative and set it equal to 0, you could find those points, but we can find them calc max, calc min, right? Calc min. I'll find this one first. It has me go to the left side. Do you remember doing this last year? Ham and ram? Yeah. Enter. Go to the other side. Enter. Enter one more time. And you get, yeah, so 2.5 is negative 1.76. And then do it again. Calculate the maximum now.
And that's the minimum?
Yeah, that's going to be the minimum. That's actually the absolute minimum on this interval, which we don't really care about, do we?
So then what is 0?
Those would be,
Critical points?
no, they're minimums and maximums. So then this other one is 0.63, 1.76. Okay, so let's talk about this. We have our graph. I'm just going to draw it really quickly on our interval, and it goes like this, it drops down, and it goes like that. Okay? Actually, it goes back up a little bit to there. And so here, this at 0, what is 0?
Minimum.
It's a minimum, yes. Are the points around it bigger than it? They are. It's kind of sunken in a little valley down here, and you're rising out of it, so it's a minimum. This point right here, which is x equals 0.63, it's 1.76. That would be a maximum. Okay, and then you dip all the way down here at 2.5, and that's negative 1.76. That's a minimum. And then you come back up to here to negative 1, which is a maximum. Okay, and that's done graphically. That's stuff that you could have done last year. We didn't really do that in Trig, though. All right, then I have one more thing. I know, it's a lot, huh? 37 minutes. Last one, number 8. I want you to draw a graph. It's like one of those open-ended questions that there's more than one answer. Draw a graph that has an absolute max at 3.5, an absolute min at 5, negative 2, on the interval 0, 10. Oh, 0 is not included. Okay, this is for you. Answers will vary.
You can't draw an absolute minimum.
You can. There doesn't have to be one, but there can be an absolute minimum.
It's open-ended?
Yeah. Like, for example,
There can only be one absolute max and absolute min.
no, not necessarily. Like this one has an absolute max and an absolute min.
But like the other one keeps going.
But it doesn't. It stops right there. The mean value theorem doesn't say that it doesn't have. It says if it's an interval, closed interval, it will have both. But it doesn't mean that if it's open, it doesn't have it. It can have both. It's just they don't a lot of times, but they do sometimes. Okay, so let's try and draw a graph of this. Let me just get rid of this one over here. Okay, here we go. I would probably approach this in this way. I'd take those 2 points that I see, 3, 5, and I'd plot that because I know it has to go through 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. And then I also know that it's got to go through 5, negative 2. 1, 2, 3, 4, 5, negative 2. Okay. That's going to be my highest point, and that's going to be my lowest point, so I'm not going to go above that point, and I'm not going to go below that one. Okay. At 0, I want an open circle, and it doesn't matter where you draw it. I probably would just draw it somewhere in there. And so I'd go like this. I'd go up here, drop down, that's a minimum, and then I'd go over here to 10, and I would just end it right there. Okay? So that's an absolute max. That's an absolute min, and this graph is on the interval from 0 to 10.
If
It can. Yeah, this doesn't have to be like a polynomial type of thing. You can have it go like that, that, that if you wanted to. Those are still maximum minimums. They're critical points. Their derivative's undefined there. So if I draw it as curvy, then the derivative at those points is equal to 0. If I draw it as, you know, straight edges like that, then that means that the derivative is undefined at those points. Either way, they're critical points.